Exercise 505 is about stationary points and the second derivative. Now for each of these curves, we're focusing just on a point. At the point, I've drawn on a tangent line. So at this first one, the tangent line at that point is horizontal, which tells us that the first derivative is equal to 0. It's a stationary point. It's concave up, so just like a happy parabola, its second derivative is positive. I might just mention the parabola in more detail. If we've got y equals x squared, the first derivative is 2x, the second derivative is 2. Happy parabola, positive second derivative. Y equals negative x squared is a sad parabola. So first derivative is negative 2x, second derivative is negative 2. So the sad parabola shape has a negative second derivative. So let's look at this one. It is horizontal at that point, the tangent, so it is a stationary point. So the first derivative is 0. As I just said, it's like part of a sad parabola, so the second derivative is less than 0, it's negative. Okay, let's look here. So at this point here, we can see that the gradient is positive, so it's greater than 0. The first derivative is greater than 0. The second derivative at this point, just to the right, it's concave up. Just to the left, it's concave down, so it's actually a point of inflection. So the second derivative would equal 0. This one is very similar. The first derivative is negative because the tangent line's going down. The second derivative again equals 0 because it is a point of inflection. Concave down here, concave up here. Those two are not stationary points because the first derivative is not equal to 0. Okay, let's look at these two. So these two, the first derivative, at that point the gradient is horizontal. So the first derivative equals 0. It's concave down here, concave up here, so it is a point of inflection. It's called a horizontal point of inflection. The second derivative will be 0. This one is the same. The first derivative is 0 because it's horizontal. And the second derivative also equals 0 because it's concave up there, concave down here. So at that point, it's a point of inflection. The second derivative will be 0. So just a note here that those red lines are tangents. And a summary, stationary point summary, a minimum turning point, like we saw here, you can find it by saying the first derivative equals 0 and the second derivative of the function will be positive because it's like a happy parabola. That gives you a minimum turning point. A maximum turning point also has a first derivative equal to 0, but the second derivative is less than 0. Like a sad parabola, it's negative. Now be careful, people do get this back to front. Always draw the little parabola shape. It will help you, whether it's a minimum or a maximum. And a horizontal point of inflection, which is these two, it's horizontal, so the first derivative equals 0, and the second derivative will be 0 at a point of inflection. Also at a point of inflection, concavity must change, so concavity changes, and we do have to prove that concavity has changed.